Hello everyone. In this video, I will explain how to interface LEDs to 8051 system and flashing of LEDs and simulation of the port. So in this block diagram, 8051 system, port 0, 8 pins are connected to 8 LEDs in this fashion. So when there is logic high on port pin, this LED will glow. Current is passed, it is forward biased, current is passed to this and it will emit light, so LED will glow. If there is logic 0 on this, LED will not glow. In the second figure, a key has been connected to P1.0 and LEDs are connected to P0. So P1.0 is to be configured as input port, P0 as output port. Now we will see the program, embedded C code to flash LEDs. That's the first program. And the second program is if the key is pressed on the LEDs, otherwise LEDs will be off. We will open Wheel IDE software. And this is the program for flashing LEDs. So include this header file register 52.h. There is a function which is declared here. This is known as function prototype or function declaration. So this function does not return anything. Its name is delay and it does not take any input, hence it is void. And the function is defined here. So main function starts here. So there is a variable key which is of type unsigned character is declared here. So while 1, so this value is always true. So this set of instructions will execute forever. This becomes a continuous loop, forever loop. So continuously LED will be on and off. So since port 0 is connected to LEDs, so by writing like this 0xFF, that is hexadecimal value in binary, it is 111111. All 8 bits are high. So in hexadecimal it is 0xFF. That means all the pins of port 0, P0.0 to P0.7 are high. Logic high is output on port pin. So which is connected to LEDs. All LEDs will be on now. So LEDs will be on till this delay function is executed. So there is a delay here. Function is called. After that delay on port 0, 00 is output. So that LED will be off and it will be off for this much delay. So this will happen continuously. So you can see LEDs flashing on and off. The delay function, there are two variables declared I and j. There is a for loop here written here, nested for loop. So for I is 0, condition is checked. Since it is true, it will enter into inner loop. Here j is 0, j less than 100. This loop will run for 100 times. After that, I will be implemented. Then its condition is checked. Again, this will run. So this loop will run totally 1000 into 100 times. So CPU is doing this for that many times. So many clock cycles are required for executing this. So that will create the delay. So now we will see how to simulate this program by simulating the ports. So for that, we have to go to project and check for the error by giving build target. There are two warnings here. There are no errors. We'll see the warnings. KEY is not used. So for this program, it is not required. Make it as comment. So this also not required. Make it as comment. And warnings coming. Sometimes warnings you should not ignore. So make it as error free as well as warning free. So whenever you make changes, save it, go to project and build target. So now you can see 0 errors and 0 warnings. This program size, data memory size is 9 bytes, X data is 0, code size is 58 bytes. So this will generate the code which is of 58 bytes. 58 bytes of code memory is required to store this program. Now to simulate this, go to debug, start, give OK. Since we are using port 0, you can simulate port 0, go to peripherals, IO ports, port 0. You can see here there are two things. One is port 0, latch content. This is the on port pin, external pin, the data on external pin. Now we can run this program. Go to run. You can see here, this is LED on, LED off. You can see the data on the latch FF00. That is happening continuously. So this is LED flash program.